So first thing first, look, this question specific. It just go to talk about binary search. So just give me a moment. I just establish all the parameters that gonna be sort of involved in this. So give me a moment. Binary search and definitely brute force. The condition set. So if we will look question specific, you just basically see the Koko eat a banana. So this eight just say that we this is basically the target, saying that the target value that within 8 hours, right, you need to finish uh, all the piles of like banana over here. So for k, right, k is basically equals to uh, the rate of eating the banana. So the rate of eating. So he say 4, right? So every hour he can eat this 4 banana, right? So I mean um, it take one hour to eat the first pile, take 2 hours to eat the second pile, 2 hours eat the third pile, and take 3 hours because we are rounding to the we being humble with the rounding of number per se. So because I mean 3 divide by 4 point something, right, but we just round up to be humble lah, to be humble. 6 divide by 4, I mean it's around 2, it's a 1 point something, but we just round up. I think this same number, wait, sorry, this is 7 for different number, then 11 for, I think it's around 2 point something, so we just round out to be humble. So 1 2 2 3 5 7 8, so total 8 hours to finish, which is exactly like our target. Okay, so that's basically how each of the parameters do actually interact with one another. So we start off with this. So I actually don't know where they get this array from, the 1 to 11, but let's just say this k array is an int array, alright, so they provide to us. So first and foremost, usually binary search question, I think what if say this is at the range, normally what you want to do for binary search specific is basically just plant your L and R to both edges, right? And then your M will be at the center, more linear towards the left usually. So I got these 11 numbers, 11 by 2 5, yeah, 5, so 1 1 2 3 4 5. Let me think. I look at their index for a while. 0 1 2 3 4. just saying you see I take the 5, there's 4 number at left, 6 number at right, not correct eh? How come it's 6 does anyone know? What the hell? Yeah, this number is like the center eh. Ooh. Okay, but you know what? Man, I don't know. So, because that's not my specialty. Okay, but the M is over here somehow. Okay, but okay. So now we proceed to do the calculation, what not have you, and then we do this all this operation. This operation I just call it the X operation. So going through the X operation, I do realize that we are eating slightly fast. So maybe our H is like somewhere around like total around like 6ish, and we say that our target actually we can use because what we want to do, what we want to have is like make the minimum as a k as low as possible. So one of the criteria was that we want the minimum of like k value, right? Because I think in terms of like k is basically your resources. Do you want to expand use as little as use minimum of my resources to actually max output? So max ROI lah, that's what they say. So so what you do here is that obviously if you go towards the right, you are spending more resources per se, and then your H will be much more efficient per se, yeah. But if you go towards the left, definitely the opposite, that will be actually argued that you use less resources, and then your output won't be as fast, right? So now you first and foremost you look at your H at this current moment. Are you fast enough or not, or can you be more greedy? And the answer is you can be more greedy, you can use less resources. So I turn towards the left. So what happens is that your R, it definitely move towards the left side of M, and your M is usually at the centerpiece. So so over here. So this time round I use the 3, I use the calculation, I do the H, and this time round my H I think it's somewhere around like 9 or 10 or something like that. And then I would then say like, wow, cannot lah, actually we this time round we need to use more resources. But the thing is this, you at start you cancel this value already, you also so you cancel all this value already. So right now you want to use more resources, what not have you. For your M, you cannot, so you put your L over here, you put your new M over here. That's what actually happen. You do the 4, usually do at the M calculation again, and then you dig your answer this time out. You realize use the 4, and then you get until your target value, which is the 8, which is very good. We can return the answer. The answer is 4. 4 is like the most optimal way that I can actually use the Koko to eat my piles of banana. Yeah. So I mean big picture specific, as you can see, a lot of like operation that goes on, but it's still lean towards the binary search per se. But in terms of like this question specific, I think the complication comes down to say that you need to identify that it does use binary search, but overall you see our operation is already using the binary search per se. So we enter into here is that the complication comes down to maybe say the calculating of like the rate of eating, right? I think that is the more complicated part. But overall, like what property we use is basically use the binary search property using the left, middle, right calculation for us to actually calculate the find the most optimal way that I can use my rate of eating, right? So you also need, I think the rule is that you need to convert your rate of eating, converted it to um, convert it to my k value, which is my criteria at the first place. My k need to be as low as possible. So your rate of eating, right? Sure, you did calculate everything, but after rate of eating, you calculate already, and you plus them together. You need to convert them into like the actual k value, which is this plus this plus this plus this. Basically, I term this x operation as part of like trying to calculate my k value based on the rate of eating, based on my k value divided by the pulse, right? So we have the a over here, the b over here, and then the c as our final output. So basically you need to know how to utilize a, how it interact with b, therefore getting your final output as c. So that's pretty much of how you transfer your ROE to k. Basically how you do the operation ABC to allow you to find the final k, right? So that's the complication part. But overall, what you're actually doing under the hood is basically using binary search for you to actually utilize the property of LMR, where you try to find the most optimal number for the k, so that you can perform the ABC and hit your target in the most optimal way. Which number over here is the most optimal one? And when talk about spell, right, when you talk about binary search, obviously we'll talk about brute force, right? You can go one by one. Obviously, but binary search always has something up its sleeve. That means it say that like the time complexity is always cut down by half. So when you talk about that, the big O time complexity will be log n, but for brute force it's always big O of n. That's what we know of. So this one, right, we can actually counter argue brute force easily, beat it out of the waters, right? So yeah, there you have it. Everything comes to an end.